In the second video for Chapter 2, we'll discuss different kinds of chemical bonds. Chemical bonds are attractive forces between two atoms. There are three basic types of chemical bonds: ionic, covalent, and hydrogen bonds. As you might surmise from the name, ionic bonds involve ions. Specifically, ionic bonds are attractive forces between two oppositely charged ions. In table salt, sodium chloride, a positively charged sodium ion is attracted to a negatively charged chlorine ion. Ionic bonds are not very strong. When an atom of sodium, chemical symbol Na, ionizes, it readily loses one electron. The sodium atom is now a positively charged sodium ion, represented by Na with a plus. Chlorine ions readily accept an electron when they ionize. The resulting chlorine ion has a negative charge. These two oppositely charged ions attract one another. The attractive force is called an ionic bond. It holds the sodium and chlorine atoms close together, forming a molecule of table salt, sodium chloride. A second type of chemical bond is the covalent bond. Covalent bonds result from atoms sharing one or more pairs of electrons. If the pair of electrons is shared equally, a nonpolar covalent bond results. Polar covalent bonds involve electrons that are not shared equally. You might think of the shared electrons as being closer to one atom or spending more time with one atom than the other. The atoms involved in polar covalent bonds do not ionize, but they end up with partial opposite charges. I'd like for you to memorize that covalent bonds between two identical atoms and also carbon and hydrogen are nonpolar covalent, while the oxygen-hydrogen bond is an example of a polar covalent bond. In this example, instead of ionizing, the two chlorines have an electron to share. Since they have identical abilities to attract and hold electrons, the two atoms are shared equally. Here I've shown them equally spaced between the two chlorine atoms. A nonpolar covalent bond results. Not all atoms have equal abilities to attract and hold electrons. Compared to hydrogen, oxygen has a much greater affinity for electrons. In water molecules, the oxygen and hydrogen atoms don't ionize, but they don't share the pairs of electrons equally. Polar covalent bonds result. Polar covalent bonds are polar because the oxygen hogs the electrons and ends up with a partial negative charge. The hydrogens have partial positive charges. These polar covalent bonds give water some surprising properties. A third type of chemical bond is the hydrogen bond. The name is somewhat misleading. Hydrogen is often involved, but that's not a requirement. First, there must be two atoms with partial opposite charges. These are the result of polar covalent bonds with other atoms. The hydrogen bond is the attractive force present between these partial oppositely charged atoms. These bonds are very weak, but also they're very important in living things. DNA, for example, has lots of hydrogen bonds, and also the shapes of proteins are influenced by hydrogen bonds. Earlier I mentioned that water behaves strangely. These weird properties are largely the result of numerous hydrogen bonds among water molecules and between water molecules and other polar substances. The red lines in this diagram represent hydrogen bonds that are possible between water molecules. Water is a very good solvent for polar substances, but not for nonpolar things. Water molecules are adhesive and cohesive. Water has a high heat capacity and a high heat of vaporization. Ice floats in liquid water. These properties are largely the result of water's ability to form hydrogen bonds with polar substances. We'll discuss these properties further in class. Let's stop here for this video.